Dear participants of the conference, I'd like to present you our report on the topic Modeling Extreme Management of Saline Water Dilution in the Ingulets River Basin. In accordance with the EU Directive, water resources management should be carried out according to the Basin principle and presupposes the presence of integral approaches. River basin is a complex system with established ecological, social, and economic ties. Therefore, the management of this system cannot be carried out by separate analytical or statistical methods. It must be considered as an integral socio-ecological economic system, the coordination of managerial decisions of which is achieved by applying the methodology of system management. We propose to use the Basin principle for system modeling, water use and wastewater disposal management in the Ingulets River Basin. Each basin has its own specifics and subsystems which should be reflected in the integrated management model. So we developed structural and functional diagram of the Ingulets River Basin system model and identified its structural subsystems, such as first, the water supply subsystem by the Dnipro-Ingulets Canal, water supply along the river channel and the filling of the Karachunivsky Reservoir. Second, a subsystem for flushing the Ingulets River from Karachunivsky Reservoir with the displacement of the saline prism into the Dnipro River. 3. A subsystem of environmental safety when discharging effluents by polluting enterprises into the Ingulets River. And 4. A subsystem of water supply for irrigation in the Ingulets irrigation system, prevention of soil salinization. Within the second subsystem, difference balance equations for the dynamics of the propagation of water and minerals in a river flow are proposed. The balance of water masses in a sequence of cells on a river section under conditions of point and diffuse sources is determined by a system of difference equations for the conservation of masses and continuity of the flow. Formula 1. The point source is given by the piecewise function of Formula 2. The balance equations for the dynamics of the transfer of contaminants after mixing have the form Formula 3, where UIN plus 1 is a concentration in the is cell at the n plus first time moment. Concentrations UI first and water resources in the first cell W first n plus 1 calculated by the formula 4 are set on the left border, boundary conditions. In the process of water flow propagation between the reservoir and the left border of the river section, uncontrolled interference C K of T from point and diffuse sources of pollution act. They affect the concentration of water resources, Formula 5. Analysis of water dilution control system showed the need to apply combined extreme control systems under conditions of uncertainty. On this slide, we can see a block diagram of the combined system. The identification of such systems begins with the identification of the open loop part of the system, Formula 6. For each of the characteristic values of the obstacle C, K of T. This means that for the disturbance effect, the value of the flow rate from the reservoir, Pi of T, the control action, the flow rate from the pipe for dilution, Fk of T, is determined. At the same time, the extreme characteristic of the control system is concentration in the initial ends section on the right border of the river Formula 7. Falls within the specific allowable interval 8, where UMPD is concentration of maximum permissible discharge, ULIM is permissible concentration of discharge in the full mixing section N. Here the function phi is expressed as a system of simulation modeling based on the proposed models 1, 2, 4 of the dynamics of the spread of pollution. UNN is the concentration in the control section is below the full mixing section on the right section of the river. If UNN less than ULIM, then environmental requirements are met. However, during the dilution process, significant excess water consumption occurs. If the concentration UNN exceeds the maximum permissible discharge ULIM, environmental requirements are not met. In both cases, it is necessary to correct the control action FK flow rates from the pipe. In the first case, the control influence Fk is increased. In the second, Fk must be reduced to achieve condition 8. To control the process of water dilution, a software implementation of the models 1, 2, 4 has been developed. On the basis of modeling, the dynamics of the spread of pollutions is calculated with the hydrological characteristics of the Ingulets River. Discharge from the reservoir P of T equals 6 cubic meters per second. Chloride concentration equal 20,000 milligram per liter. Discharge from the storage pond F of T equal 1.6 cubic meters per second. Obstacle value C of T equal 2,000 milligram per liter. At the same time, the concentration of chlorides in the nth control section at a distance of 25 kilometers from the dilution point is 3,900 milligram per liter and is in the range. A comparative analysis of the actually carried out water dilution in the period from January 20 to March 15, 2021, with modeling the process according to the proposed algorithm, showed in both cases satisfactory water quality in terms of chlorides. However, in terms of water consumption for flushing, the control modeling option has significant advantages. Water savings are about 17.5 million cubic meters. So the combined system of extreme control of the dilution of saline waters allows optimizing the process according to ecological and economic criteria. This is achieved on the basis of mathematical modeling of the spread of contamination and control of water quality in the fully mixed section. Maintaining water quality within acceptable limits provides a choice of management solutions that minimize water consumption for dilution of saline wastewater. Scenario analysis of water dilution management on the example of the Ingulets River and comparison with dilution under the existing regulations of 2021 confirms the possibility of savings up to 17 million cubic meters of wash water. Formalized mathematical models can be used to model diffuse and point sources of pollution and water dilution in other river basins. However, the structural and functional diagram of the management system must be adapted to the hydrological conditions and parameters of particular river. In the future, the combined system of extreme management of the dilution of saline waters should be supplemented with a system for collecting and transmitting information based on telecommunication technologies. In addition, it is necessary to jointly consider the process of drainage of saline waters, in particular to optimize the accumulation of water in storage ponds, taking into account the criterion of water quality. The channel should be washed using a technology that minimizes water consumption and ensures the ecological improvement of the river. Thank you for your attention.